Okay, let's dive right in. We're all kind of blown away by what modern AI can do, right? But there's this hidden cost to all that power, a sort of brute force approach that's just incredibly inefficient. Today, we're going to explore a really fundamental shift away from that brute force towards something way more elegant. And that brings us to the central question we're digging into. When you're chatting with a large language model, are you really witnessing intelligence? Or is it just an unbelievably powerful engine that's just churning through math on a scale that's hard to even imagine? This line from our source material just perfectly captures that nagging feeling. The results are incredible, no doubt about it. But the process itself, it feels less like genuine insight and a whole lot more like just overwhelming computational power. So what exactly is this engine of brute force? Let's pull back the curtain here and really name the culprit behind all this inefficiency. And the answer, when you get right down to it, is something called matrix math. And believe me, it is everywhere in today's AI. So why is all this matrix math so expensive? Well, as you can see, there are a few big reasons. First, just the sheer volume of calculations is astronomical. But the even bigger problems are the constant shuffling of data back and forth between memory and the processor, and this wild fact that the models are always recalculating the same basic relationships. They're essentially relearning what words mean every single time. Now, here's the part that might really surprise you. The biggest energy hog, it isn't actually doing the math. Nope. It's the simple physical act of just moving all those numbers, all that data, from the system's memory to the processor. That constant back and forth, that's where most of the power is just getting burned. And this line just illustrates the whole philosophical crack in the system so perfectly. We're using a tool that's meant for building the scaffolding to do the final job. It's like we're constantly rebuilding the entire support structure for every single thought instead of, just using the building that's already standing right there. So if matrix math is just the temporary scaffolding, then what's the permanent building? Well, the source material argues the answer lies in a concept called latent space. Let's take a look at what that actually means. Okay, don't let the name intimidate you. Latent space sounds super technical, but the idea is actually pretty simple. Just think of it like a highly efficient internal map of concepts. Instead of dealing with messy, complicated words, the AI plots everything onto this map where ideas and relationships and context all have a specific location. And this is the beautiful, simple rule that governs this whole map of meaning. The concept of king is located near queen, but it's way, way far away from bicycle. See? It's an incredibly intuitive way to organize the world, turning complex language into simple geography. But here's the crucial point. This is the heart of the whole inefficiency problem. Even though today's AI builds this elegant, useful map, it treats it as completely disposable. After just one use, it throws the entire map away and then meticulously rebuilds it from scratch for the very next task. It's just wildly wasteful. And that leads us to the core paradigm shift that's being proposed. What if we just stopped throwing the map away? What if, instead of constantly recalculating everything from zero, we simply learned how to navigate the map we've already built? This slide just lays out the difference perfectly. Today, we're stuck in this matrix-first world. It's all about constant recalculation, treating that amazing map of meaning like a disposable piece of scratch paper. The proposed latent first future, that's all about intelligent navigation on a persistent, permanent map where meaning is reused, not rebuilt. And look how much simpler the process becomes. It's just 3 steps. First, you project your question or your input onto the map. Then, you just navigate around to find the answer using really cheap geometric operations. And finally, you generate your output from that new location. No more rebuilding the whole world from scratch every time. So what are the bigger implications of a shift like this? I mean, this is about way more than just saving electricity. It's about fundamentally redefining what it even means for a machine to be intelligent. So why is navigation so much cheaper? Well, as you can see, you're doing way fewer calculations, you're moving a lot less data around, and you're only activating the parts of the map you actually need for the task. It's actually a lot like how our own brains seem to work. We don't reprocess all of reality from scratch every millisecond. We navigate our existing model of the world. And this is where it gets really exciting. This means we could finally move beyond this bigger is better arms race in AI. Instead of building ever larger models that just approximate understanding through brute force, we could build smaller, much more efficient models that have a richer, more persistent internal map of meaning. I mean, what a powerful way to redefine things. For so long, we've been measuring AI intelligence by its raw computational horsepower. This new way of thinking suggests that true intelligence is actually about efficiency, about elegance, about achieving the most with the absolute least amount of work. And that's really the ultimate takeaway here. The next great leap in AI might not be louder or bigger or more powerful. It might actually be quieter. It'll be that moment when the machine finally stops frantically rebuilding its world over and over and can just operate within it, doing less work because for the first time, it actually knows where it is.